This is example 3 from the cosine law. Okay, in triangle ABC, A is 11, B is 5, and angle C is 20. Okay, angle C obviously is the angle between the sides A and B, right? Because it's the different letter. Okay, so if I just draw angle A, or side A, that's 11, and I'm going to draw a nice little 20-degree angle here. Okay, all right. So I can actually draw a half-decent scale diagram here. Or not scale, sorry, it's not a scale diagram, but a half-decent sketch um, of the situation. Okay, so that's A, that's going to be, nope, sorry, that's A. It's opposite 11, B is opposite 5. Okay, and then C, that's our 20-degree angle. We don't know side C, okay? So that's our diagram. We want to determine the length of the unknown side and the measures of the unknown angles to the nearest tenth. Okay, and since you have two sides and their included angle, a good place to start would be to find the other side using the cosine law. So c squared equals a squared plus b squared minus 2ab cos c. Okay, c squared equals 11 squared plus 5 squared minus 2 times 11 times 5 times cos 20. All right, when you do that, you will find that c squared is 42.63, and so c is going to be 6.529. Okay. Then you can find your other angle. Okay, now you can tell absolutely by looking at this that angle A is going to be obtuse and angle B is going to be acute. Okay, there's no question about that. So you can use the sine law here without any trouble. If you did use the sine law to find angle A, you would then have to take your answer and subtract it from 180. Do you want me to show you that? If I decided to go sine A over A equals sine C over C, okay, and then I would go sine A equals, and then I'm going to take A, that's 11, times sine 20 over 6.529, okay, whatever I found there on my last answer. Okay, so I just punch that into my calculator, 11 times sine 20 divided by 6.529. Okay, take the second sign of that answer, and I get 35. Okay, about 35. Okay, so sine A is 0.5762. A is 35 degrees. Oops. No. Actually, A is 180 minus 35, which is 145. Okay. All right, so that's a really good example of where you could use your sine law. You have all the right information, but looking at your diagram, you know that's going to have to be obtuse, so you know you're actually going to take the supplement of the answer that your calculator gives you. Okay, and I'm just going to show you actually here. If you had used the cosine law, because you have enough information to use this cosine law to find angle A, right? Because you know that cos A, okay, let's just make some room here. Okay, looking at the formula that you had, that we just looked at in the last example, cos A equals b squared plus c squared minus a squared over 2bc, okay? And so that would be 5 squared plus 6.529 squared minus 11 squared over 2 times 5 times 6.529, right? Just like that. And you're going to end up with angle A. It's going to give you the right answer. It's not going to give you the supplement like sine does. Okay, so that actually is. Let's just skip this part. Okay, I'm just copying out of the book here, but it will give you an answer of 144.8 degrees. Okay, so the cosine law will give you the right answer. The sine law, you have to make sure that you have the right thing for your diagram. And if you can't tell, try to use the cosine law. Okay, when you get done solving a triangle, here's what your answer should look like. Okay, side A is equal to 11, B is 5, C is 6.5 because it asked for it to the nearest tenth of a meter. Angle A is 144.8. I guess I wanted that to the nearest tenth of an angle. Angle C, we were given, is 20. Okay, and you're actually going to have to subtract the total of those two from 180, and you're going to get your last angle, which is 15.2 degrees. Okay, you can take a look up at your diagram, make sure that that makes sense. This is a smaller angle, right? You can kind of tell because this line's a bit longer, you know, it's a little more, a little smaller. Okay,